8.3 finds special products of polynomials. The diagram to the right shows a square with a side length of a plus b. The area of the square is then represented by a plus b squared. Now, to the right here, we can cut this big square into 4 smaller shapes. One would be this big square here, so the area would just then be a times a, and the other small square would be b times b, which is b squared. And we would get 2 rectangles that are the same. So the length of this rectangle is a, and the width will be b, a times b. And the same goes for the other one. A times b makes a times b. So then we can write the area of the square as a squared plus ab plus ab plus b squared, which then makes a squared plus 2ab plus b squared. And now we get this pattern, which we call the square of a binomial pattern. Whenever you get a binomial that's squared, you can immediately expand this squared binomial as a squared plus 2ab plus b squared. And for this case, when you have a subtraction sign in between, it will be a squared minus 2ab plus b squared. And as to why this is subtraction, I will leave it for you to think about. Okay, we're going to look at an example here. First, to expand the first binomial, you can take x squared plus 2 times x again times 8. And then we're going to add that to 8 squared. So again, the x squared will represent the a squared here. 2 times x times 8 will represent 2ab, and then 8 squared will be your b squared. And then your signs are still positive. Okay, so you pay attention to that. And then now, x squared plus 16x plus 64. And the same thing would go for another one with the subtraction sign for the binomial. X squared minus 2 times x times 7 plus 7 squared. So the x squared will be your a squared here, followed by the subtraction sign, and then 2ab, 2 times a times b, and then your b squared with the addition sign in between. Okay, now we can further simplify this as x squared minus 14x plus 49. Okay, now we're going to look at the sum and difference pattern. So by the FOIL method, I can expand this as a squared minus ab in the inner plus ab and the outer minus b squared. Now I can cancel out the middle to get a squared minus b squared. So whenever you get a binomial that's multiplied together and the first numbers are the same and the last numbers are also the same, then you can simply take the square of the first number and subtract the square of the second number. So if we look at this example here, m and m are the same. 6 and 6 are the same. And then you have a subtraction sign and a positive sign. So we can use the sum and difference pattern and simply take m and square it. And then the subtraction sign. And then we can take 6. Don't worry about the sign, okay? Just take 6 and square it. So here I have given you 1, 2, 3 special products of polynomials. Okay, let's practice using the square of a binomial to find the product. So here I have 3m plus n squared. So I can take 3m squared plus 2 times 3m times n plus n squared. And then I can further expand this as 9m squared plus 6mn plus n squared. And the next one is a little bit more complex because you have negative signs, so you need to be careful. So this one, negative x squared, you'll have to look at this as 1. And then we have a subtraction sign here, so subtract 2 times negative x times 2y. So this is a, this is b, and then plus 2y squared. And then we make positive x squared. And here a negative, negative makes positive. 2 times 2, 4xy plus 4y squared. And for the next example here, we have to use a sum and difference pattern to find the product. So I know that 9 and 9 are the same for two binomials, and 4t and 4t are also the same. So I can take 9 squared, and here we have a subtraction and addition sign. Subtract. I'm going to take 4t and I'm going to square it. Okay, and again, the other one will be the same, 3m, 3m. I'm going to square it. Plus, minus, so you can use the pattern that I explained earlier. Square it. 9m squared minus 121n squared. And now, I'll teach you a technique. I'm going to use special products to find the product of 26 times 34. Now I can rewrite 26 as 30 minus 4 and 34 as 30 plus 4. And now I can use the sum and difference pattern to further simplify this. So 30 squared minus 4 squared. 900 minus 16 gives you 884. Okay, now we have to perform the indicated operation using the functions f of x equals 4x plus 0.5 and g of x equals 4x minus 0.5. Now part 8 wants you to multiply f of x to g of x. So I can substitute f of x for 4x plus 0.5 and substitute g of x for 4x minus 0.5. Now we can see a pattern here again and use the sum and difference to simplify this. So 4x squared minus 0.5 squared. And this makes 16x squared minus 0.25. And the other one, f of x, is 4x plus 0.5, and then we're gonna square this. Okay, now we can use the binomial pattern and expand this. So I'm gonna take 4x, I'm gonna square it, I'm gonna double 4x times 0.5, and I'm gonna take 0.5, I'm going to square this. So I get 16x squared plus 4x plus 0.25. Word problem. The color of the dark patches of a border collie's coat is determined by a combination of two genes. An offspring inherits one path color gene from each parent. Each parent has two color genes, and the offspring has an equal chance of inheriting either one. The gene B is for black patches. The gene R is for red patches. So these would be the black gene, and this would be the red gene. Okay, any gene combination with a B results in black patches. So if we have B times B here, this would become a black patch dog. B times little r would also be a black patch dog, and so forth for this one as well. Suppose each parent has the same gene combination, BR. The Punnett square shows the possible gene combinations of the offspring and the resulting patch color. Okay, so again, B times B, B times R, B times R, and then we have R times R. And of course, this dog would get the red patch. And just to review, the big B will we call the dominant gene. And the little r would be the recessive. Okay? And let's see, part A. What percent of the possible gene combinations of the offspring result in black patches? Well, there's 4 possibilities. And I told you earlier that if you have a B, then it will result in a black dog. So let me first write all the combinations, BB, BR, BR, and RR. And 3 of these will result in black. So this represents 75% of the possibilities. Moving on. Show how you could use a polynomial to model the possible gene combinations of the offspring. Okay, so first, model the gene from each parent, and that would be 0.5 B plus 0.5 R. Why 0.5? Because there's an equal chance that a collie inherits a black or red gene from each parent. So the possible genes of the offspring can be modeled by the square of 0.5b plus 0.5r squared. So this will also be the area of the Punnett square. And now I'm going to expand this model. So it becomes 0.25 b squared plus 2 times 0.5 times 0.5 again, big B, little r, plus 0.25 r squared. And then we're going to write this again. And then this would be 0.5 BR plus 0.25 R squared. Now, what does this mean? This means that 25% of the dogs will get black patches, and this means 50% will be black as well, and this means 25% we get red patches. Now this leads us to the next question. What percent of the possible gene combinations of the offspring result in red patches? Well, it would be 25%. And this concludes the lesson.